Hello everyone, welcome back to Amin Club. Today we have a nice exponential problem that is a to the power b minus b to the power a is equal to 17. So we have to find the value of a plus b. Now let's start our solution. That our problem is a to the power b minus b to the power a is equal to 17. Now here a to the power b whole to the power, if we just take that 2 over 2 in powers. Similarly here b to the power a whole to the power 2 over 2 is equal to 17. As you know that 2 over 2 is equal to 1, so there is no difference if we just like this. Now here this 2 over 2 can also be written as a to the power b whole to the power 1 over 2 times 2. Similarly b to the power a whole to the power 1 over 2 times 2 is equal to 17. Now, as we know that by exponential identity, if we have a to the power m whole to the power n, it is equal to a to the power m times n. So here that a to the power this b times 1 is b over 2 whole squared. Similarly, minus b to the power a over 2 whole squared is equal to 17. Now, let us consider this a to the power b over 2 is equal to x and b to the power a over 2 is equal to y. So, just let here a to the power b over 2 is equal to x and b to the power a over 2 is equal to y. Now, substituting this value here, then we will get it will be x squared minus y squared is equal to 17. Now x squared minus y squared, according to algebraic formula, we can write x plus y times x minus y is equal to 17. So here we can factorize this 17 like that 17 1 times 17 is equal to 17. Similarly, 17 times 1 is also equal to 17. Here we see that this x plus y times x minus y, here actually x squared is greater than y squared. If x squared is greater than y squared, then x must be greater than y. It means that x plus y is also greater than x minus y. Hence, we know that our first factor is greater than second one, so we just take here those values of 17, those factors of 17 in which first factor is greater and second factor will be less. So here we see that it is rejected because first factor is less than second one, so we just take this case here. Now x plus y times x minus y is equal to that 17 times 1. Now our greater factor, which is x plus y, is equal to greater factor, which is 17. So x plus y is equal to 17 and x minus y is equal to 1. So we get to system of equations here. Now if we add these two equations, we have x minus y is equal to 1. So adding these two equations, here we see that plus y is cancelled out with minus y. So x plus x is 2 times x is equal to 18. And similarly, we get the value of x here, 18 over 2 is 9. So the value of x is 9. Now if you put this value of x in this equation, x plus y is equal to 17 or x minus y is equal to 1. So putting here, then it will be that value of x is 9 minus y is equal to 1. So here we have that minus y is equal to that 1 minus 9, and y is equal to, here we have minus y is equal to minus 8. So cancelling this negative sign on both hand side, we get the value of y which is equal to 8. So here we have value of x is 9 and y is 8. But we just here suppose that x is equal to a to the power b over 2 and y is equal to b to the power a over 2. Recall the supposition here. So here we have, now recall our equations. Here we see that a to the power b over 2 is equal to x and b to the power a over 2 is equal to y. But here x is equal to 9, y is equal to 8, then it will be a to the power b over 2 is equal to x is 9. And similarly b to the power a over 2, y is equal to 8. Now we are going to find the value of a and b from these two equations. So here we have a to the power b over 2. So if we just take squared on both hand side, then it will be 9 squared. Similarly here b to the power a over 2, we are going to take squared on both hand side. Now our first equation will be, here this 2 is cancelled out with 2, we get a to the power b is equal to that 9 squared, and this can be written as 9 is 3 squared whole to the power 2. So a to the power b is equal to 3 to the power 4. Similarly here we have, this 2 is cancelled, we get b to the power a is equal to this 8 squared, we can write it like 64. So b to the power a is equal to 64 can also be written as 4 cubed. Now here from these three equations, if we just compare bases and power, so we have here base is equal to this 3 and power is equal to 4. So by comparing bases and power, we get a is equal to 3 and b is equal to 4. Similarly from this one, we see that here b is equal to 4 and a is equal to 3. So we, here we have value of a is 3 and value of b is 4, both are same. So our value of a plus b now, as we have to find the value of a plus b, so a plus b is equal to value of a is 3 plus value of b is 4, then a plus b is equal to 7. So it is our final value of a plus b, where a is equal to 3 and b is equal to 4. Now we can just verify our problem here. For verification, we have to recall our problem. A to the power b minus b to the power a is equal to 17. So here value of a is actually 3 and b is 4. So we have 3 to the power 4 minus 4 to the power 3 is it equal to 17. Now 3 to the power 4 means 81 and minus 4 to the power 3 is equal to 64. Is it equal to 17? Now if we just subtract 81 and this 64 from 81, we have 7 and 1. So 17 is equal to 17. Now our left hand side is equal to right hand side. Hence we prove that the values of a and b is true, is valid for this problem. So our final answer is a plus b is equal to 7. Now we are going to just review our problem here step by step. So our final value of a plus b, which is equal to 7. Here we have a plus b is equal to 7. It is our final answer. So that's it for today. Don't forget to subscribe my channel. Thanks for watching. Have a nice day. Goodbye.